All right, here we go. So you've been here for the whole day. I'm sure you've heard of software supply chain security, six-store attestation, SALSA, etc. What we are going to talk about here today is the security itself of the open source components that your applications are consuming, especially the containers that your applications are being built upon. The talk is titled Debian-inspired container first Linux distro, and I'll just get to that in a minute. So I'll take a bit to introduce Abhishek, my co-founder. He's been a cloud leader for 13 plus years. He was the co-founder and CTO of housing.com. In case some of you know about it, scaled the infra there to quite a large scale. I'm Abhimanyu. I was also the co-founder of housing.com, and since then, I'm an engineer turned data scientist turned product manager, and now I'm an entrepreneur. At Koalalab, what we are doing is we want to solve a lot of important problem sets around software supply chain security. We have a couple of open source tools, Bolt and Pinny, which are in software supply chain security. You can go to Koalalab Inc. on GitHub and check them out. But today's talk is about secure or minimal base container images and why they have become the security standard. The current solutions that are out there, in the open source community, basically, can you find minimal containers on Docker Hub? And then we talk about, our own approach to reshaping or rethinking Debian from a ground up and looking at, how we can create secure base container images from top of that. So Abhishek will talk about Debian-based containers, where the bloat is in them, and modernizing them from a security perspective. What are the solutions? He'll talk about some of the results, and in general, enhancing this software supply chain ecosystem or security in the Debian ecosystem. So I think unless any of you has been living under a rock, you definitely know about minimal base container images. So I would say in the last 10 odd years, ever since Kubernetes has come up and has changed the software development lifecycle, the overall SDLC has become very what I call containerized. The base has gone from a VM to a Kubernetes control plane, and that control plane runs a bunch of open source and a lot of containers. So everything from your languages like Python, Java, Go, you use them as containers. Your cloud native stuff for observability like Prometheus, Nginx are also containers. The databases, MongoDB, MySQL are also now being consumed as containers. But interestingly, what has happened is the virtual machine to the container era transition has led to bloated containers. The VMs or OS, you are used to manage complex life cycles. And if any of you have done work on that, there are a bunch of these very basic Linux commands that you have to use in those VMs. But containers are completely different. They're meant to run single runtime processes in isolation. So why should the containers have all of the bloat that is there in the virtual machines or in the base OS? So that's what our talk is about. So this is something that I was just doing before the talk. If you just look at, this is a slightly older Python image, Python base image, which is a Python 3.9. I think this was probably 3 months ago. And that itself has 115 different packages. If you just run a SBOM analysis using Sift or any of the other tools. And it has stuff like core utils, dash, bash, and it has probably Perl and 80 different more base packages. And if you really look at it, the fact that container is a single runtime isolated process, it does not need any of these packages. I was just checking the latest Python Slim image as well just before the talk, and that itself also had 105 different packages. So what happens is when you have all of this bloat in your containers, it increases your attack surface. And one of the biggest issues with that is if you have a very large footprint or an SBOM for your containers, it leads to much more patching and upgrading cycles than you would normally want. These extra packages, sometimes, a lot of security people will say that they aren't reachable because they aren't interacting with your application. But the security world is a cat and mouse game. Today, those packages may be unreachable, but they can become reachable tomorrow. And obviously, these base container images need to be more minimal because smaller container images lead to faster boot time for containers. Now, having said that, the industry does know that we require minimal base container images, and there have been certain solutions. So if you've heard of Alpine-based containers, that is something that a lot of people might know about. Or you can also build from scratch or distro-less containers. And there have been some modernization efforts from the distros itself. Specifically talking about Alpine, Alpine was a Linux built for embedded systems, and over time it has become a force fit to focus upon the minimal base container program, but it's still like a force fit solution and not a real answer. The other problem that you would see is the base C library that Alpine uses is muscle, but more or less, a lot of the Linux packages are built on glibc. So there are some issues around DNS resolution and a lot of other stuff that people have talked about in detail. And we'll link to this PPT later itself. So talking about from scratch images, so this is something that has been evangelized for the last few years. And my thought process to that is that this is a really tough sell to be solved to the developers. It's almost like reinventing the universe to make, apple pie. And you have to start with a Docker image from scratch and add all packages that you would require for a container image. But my thought process on that is there has been a lot of hard work that has been done by the distros and by the open source community on tooling around containers. So why not take why not use that, and rather than go to create container images from scratch. And obviously there are other drawbacks as well. For example, you can miss out on the metadata of each of those packages, leading to scanners not being able to use these containers or not being able to scan these containers. And as I mentioned earlier, there have been some solutions around modernizing the distros, and there are some slim containers that you can download from Docker Hub, but these are really half-hearted solutions, and there hasn't been a full effort to actually create minimal containers. So yeah, I think this is what the talk is about. Can we do better? And I think our talk is taking Debian and rethinking some of those processes to create minimal containers. And Abhishek, you'd talk about it?
Sure. So yeah, the question is, can we do better? So to answer that, first we need to look the root of the problem. Let's take a look under the hood of a container image built on top of Debian. And we will see where the bloat actually comes from in case of a Debian distro-based containers. So first, bloat comes from the maintainer scripts runtime dependencies. So whenever you install a package, there are maintainer scripts associated with that. And those need some kind of runtime to execute. Given the packages are packaged with certain assumptions, like there will be Perl or Python in the container. So they use those runtimes for maintainer scripts as well. So even if you are not installing Python, you might need it just to install that package. Second is essential packages. From a Debian system, you cannot remove certain packages because they are marked essential. This is done considering the VM lifecycle, the complex lifecycle that a VM goes through, the upgrades and whatnot, which is not actually applicable to a container. A container is always built from scratch, and if you want to change anything, you again build your container. You want to add a package, you add that package to your Docker file, and then you again build that container. You will not going to change a container. So in case of a container, nothing is essential. And the third is the whole package management stack. You are never going to use a package manager in your production images or in the actual container when it is running. So the whole package management is unnecessary. But if you look at a Debian-based image, 59 packages are there just because you want to run APT. So what's required? So we need to modernize Debian or create a Debian-based distro that can give you minimal container images with the comforts of a distro. So what all we need to do for that? So first thing that we need for that is something called a portable and drop-in replacement for the package management itself. So for that, we have built something called Captain. Soon we are going to open source it. So Captain is a portable drop-in replacement. It gives all the commands that are relevant to a container that to be used as APT. So you can add captain to your container and run commands like captain install, captain update. That is the use case of a package management. And the other is nightly build of your packages from source so that you always have a CV-free version of your packages available. So these are the two things that are required to be able to create minimal and up-to-date and secure containers. And yeah, that's an exercise that needs to be done with Debian. So yeah, so to summarize, like you need a minimal package universe and a portable package management stack, as well as no essential. So to achieve this, we need to build all the packages from source and modify or build them in such a way so that the dependency tree is absolute minimal. For example, debconf is not required in a container, so you can remove that from the dependency tree of any package. And similarly, the maintainer scripts that are part of packages, which are added at the time of creating these packages or building these packages, those needs to be either non-existent or minimal in nature. They should not require like a variety of runtimes just so that you can install that package. So I will take a unique example of base files, which is like base files is the package that creates the base layout. We generally don't need to do it because we always have a running version of a distro. But to install a base file like from the Debian archive, you need a shell, you need surprisingly you need awk as well, it's a dependency, and few more runtimes. Whereas base files is just it's just the file system layout. It should not require anything. And if you want to build a container from scratch, you need the first package that you need to add to your container is base files. So if you look at the base files package maintainer script, this is an example of it. It's a shell script. So how to break this cycle or loop where to install base files you need shell, but to install anything in your container, let's say you have started from scratch, you need some kind of, you need base files. To install shell, you need base files, and to install base files, you need shell. So how to break this loop? So one solution that we had was, why not just rewrite it in a Golang and make a binary which won't need any other, which don't need any kind of runtime. Doing that enabled us to like install base files using Captain, the package management stack, which is again a Golang implementation of APT. So that way, when I start my start my package or my container from scratch, I can first add base files using Captain, and then I can add as many packages or whatever package I want in that container. This gives me a very precise control over the SBOM that like many people before me talked about like how important they are and like monitoring. But this gives me a very precise control. I will have only the components that I want in my container. So Captain, the drop-in replacement for APT, let's see that in action. So here I have taken a scratch container, started with a scratch container, and just added Captain as APT. Like I have just given it the name APT just so that you can you can run commands APT and feel it like it's APT, but it's actually not APT. So the next is, so now I am using Captain. I can run an APT update to sync the package metadata from the archive. Then I can install whatever packages I want, like apt install nginx, CA certificates. And then we have added a command to Captain that's auto remove that. Captain removes itself from the container. So that way, in the final container image, there is zero trace of the package management, like zero footprint of package management in the final container. And finally, there are few steps to just copy all the layers, like compress all the layers so that the final image is really minimal in nature. And yeah. So this is Captain in action. Like we have built a nginx image using Captain and rebuilding all the packages required to install nginx, by rewriting all the maintainer scripts involved in those packages. we were able to create a minimal Nginx container image. So let's just compare that. So if I run Ceph to check the SBOM of an Nginx latest image from Docker Hub, I'll see there are 150 packages in it. If I do the same thing from the container image built from the Docker file I just showed you, it has only 32 packages. So the SBOM has shrunk by 80%. Similarly, if I run the gripe scan on it, I can see that there are 160 vulnerabilities over here. Same thing if I done for the container created using Captain and the packages. There are 0 vulnerabilities over here. So, yeah. So these images not only just have 0 vulnerabilities, but due to like the SBOM being shrunk by 80%, like their vulnerability accumulation rate has also shrunk by decreased by 80%. So like if you look at these images, let's say a quarter from now, they would have gained 80% or even at times 90% less vulnerabilities over that course of time. So few thoughts on this, we are rethinking the whole Debian, modernizing, and the idea is to improve this whole software supply chain. First is to give you the control over the SBOM, and the other is to give you the latest packages built, nightly built, so that you have the CVE-free version. And few other things that we are doing together with that is reproducibility of the packages, SALSA, provenance, and attestation, and build time SBOMs, so that if I use some tool to generate the SBOM as an afterthought, it works on metadata. If I remove the metadata, the SBOM changes. So the better is to trust the image or trust the software from the supply chain it is coming from. So if you generate the SBOMs at the build time, you will know exactly what is going in the container, what is exactly going in what components are used, and you will exactly know what you have done to the container. So build time SBOMs for that. So yeah, that's it. Thank you. Sure.
You want questions?
Hi, thank you for your presentation. So you mentioned you use nightly builds of packages. So does not nightly build, they are more susceptible to supply chain attacks? Because for example, if you see the XZ utils attack, the vulnerable, the malware that got into the Debian nightly builds, because that is the first line where the packages are there. So don't you think that's also there's a risk to building nightly packages instead of patching old packages?
So we are doing nightly build, but we are also maintaining the versions. For example, you will get the patch version that was released from the upstream, that only. You will not get the latest, let's say, the commit from the source. We are not building that source. By nightly builds, I mean, let's say you are building Nginx, so it will have some development, build time dependencies. It will have some other dependencies. So the whole packages as well as the container with all the dependencies and transitive dependencies will be updated. So that's what I meant by nightly builds.
Right. And how can I download your containers and use it?
Soon we will release on our website.
Okay, thank you.
Hey, I just wanted to know, how is this different from Google's Distroless images?
Right. So Google's Distroless, if you look at the final end product, we try to be not different from that. But the process with, I showed Captain in action and the Docker file example, it's anyone can create images like Google's Distroless. You might have a requirement that is not covered by Google's Distroless project, right? And more often than not, that is the case. Requirements need more extra packages. So at times people end up, let's say, patching or hacking their way to adding some packages to Google Distroless, right? So, but then you run the risk of, let's say, missing out on metadata or running out on the exact SBOM. So why not create a distro-like experience to create Distroless images?
So just to add to what Abhishek said, what the whole idea is that we've taken the distroless philosophy and applied it on Debian. And what Abhishek added is, even after distroless images, you still need some custom packages on top of your containers. And our approach gives you that control over those containers to be able to have any extra packaging that you might want. But broadly, it's the same. It's distroless concept applied to Debian.